MATLAB is so proprietary and it's not open, it's closed, and things like that. It really kind of depends on your definition of what open source means. Previously, you would have to do all this kind of back and forth data management and files and things like that. Now you could literally optimize or do some kind of parameter sweep with your simulation in Python.
What motivates me as an engineer to go from Python and maybe try the MATLAB way or the Simulink way? Why would I do that?
My very short answer is, how much time do you have? I love to write code, but I love my time. If I'm trying to train a machine learning model, I'm going to pop open the classification learner, hit two buttons, one to do parallel and one to just train all. I didn't have to write a whole bunch of code. You have your data scientists or your AI people working in Python or PyTorch, whatever. You have your sensor people working in MATLAB, and you have simulations going on in Simulink and tests going on in some C++ thing. That's absolutely where you want to start thinking about integrating. Fairly similar syntax-wise. If you're a Python developer, you could be an excellent MATLAB developer.
All right, ladies and gentlemen, we have Heather again on the show. You've been in another podcast with Jan. Today it's about open source software with MATLAB, the 3 Ps: principles, practices, and Python. Maybe give us a quick introduction to yourself, Heather, and then what does this OSS even mean?
Yes, thank you so much. So I'm really happy to be here. Glad to be back talking about our favorite languages and open source. So I'm Heather. I am a product marketing manager for MathWorks. I primarily focus on MATLAB. I do a lot of tutorials and blog posts, things like that, sharing kind of expertise largely around interoperability with different software, especially Python and other open source libraries, and a lot of AI. My background is in physics, and through that, I did machine learning and focused on that during my PhD. So that was how I came to the MathWorks, and tend to, of course, since the AI part is present, you tend to use a lot of different languages together. So that's kind of basically what I do, help users kind of combine languages and get the most success out of their projects.
Yeah. Sounds super exciting. Maybe to get started, could you share kind of a little bit of the background and your involvement with OSS and MATLAB in particular?
Sure. Yeah, and so in general, I'm a huge open source fan. I've always have been, especially during my PhD. In physics, you're using all sorts of different, equipment in the lab and, different analysis techniques. So you would use a little bit of everything. And I was so excited about this world of open source. So one of the first things that I did, I was a contributor to pizza.py. So primarily because I loved the name so much, but it's a molecular dynamics simulation package. So I was using that a lot and combining that with MATLAB, all sorts of things. So that was kind of my first exciting, entry to the open source world, at least as a contributor. And throughout, I guess, of course, huge Linux fan, lots of open source household, basically, in my world. And so one of the things that always struck me about MATLAB is that people would say that, MATLAB is so proprietary and it's not open, it's closed and things like that. And I'm like, well, it really kind of depends on your definition of what open source means. Right. So to me, it is about transparency, communication and access to the software and documentation and support for the community. And those things have always been present for MATLAB. So I think it's been an excellent couple of years at MathWorks because we're so excited about the open source world and, being able to talk to people and start getting more into this.
Yeah, I think what people ignore in the conversation, it's more like, it's so not maybe complex, but they try to condense it or trivialize the conversation by saying, they just refer to the pricing. Just because MATLAB costs something, if you want to use it for commercial purposes, it's not open source, therefore it's bad. I'm not sure if this is kind of a logical argumentation, but this is what I heard from people.
Sure. And it's fair, actually. I feel like that argument might be fair because if you are trying to, you're a researcher and you want to share your work with the world and it's in MATLAB, you have to assume that person has a MATLAB license. But that's not actually the case anymore. So we have a MATLAB basic license where you can get 20 hours a month. It's online. So it's really we've come a long way at MathWorks, being aware of some of the challenges that people have whenever they're trying to work in the community. And, if people don't have access to MATLAB, they won't be able to use the work. So really trying to make that not an argument anymore, because there is a free option if people don't want to commit to a full desktop license for whatever reason. And one of the things that I love is that you can even put, if you have, for sharing, say, an example or a bunch of code on GitHub, you can actually put a little button that says open in MATLAB online. And again, even if you don't have a MATLAB license, you can open it up, you can run it right there, you can get that 20 hours a month, and you don't have to worry about that anymore. So I think a lot of, it's nice, because I feel like those arguments are starting to be less valid on the other side, nowadays.
Yeah, I think MATLAB is definitely, or MathWorks, I should say, makes a step into the right direction. I think, Heather, you describe there's three approaches that you describe, like OSS in combination with MATLAB and Simulink. We have OSS on top of MATLAB, we have it within MATLAB, and alongside MATLAB. So what is the differentiation between those three approaches?
Yeah, that's a great point. That's exactly kind of how we think of this, right? So open source on top of MATLAB is sort of what you imagine, the MATLAB file exchange, the GitHub community, people that are building their own toolboxes or their own packages to share on top of MATLAB. So that's been going on for a very long time. I think the first version of file exchange was 1991 in an FTP server. So this is not something that is new. It's something we've been supporting forever. Well, I didn't use it then, but so that's kind of on top of, and that's been just going on forever. The open source in MATLAB or inside MATLAB, this has also been going on forever. So like many software packages and many things that you see, there is some open source built into, the guts of MATLAB. And my favorite example is very historical, because it's LAPACK or LAPACK, however you want to say it. And probably your audience, whether they know it or not, they've been using it for a very long time. So any software that uses linear algebra libraries, which is literally almost all of it behind the scenes, that's LAPACK. And Cleve, the inventor of MATLAB, was a longtime contributor way before MATLAB was even invented. So he, kind of invented the first version, and MathWorks and a bunch of developers continue to support and develop with LAPACK. So that is my favorite example, since that existed before MATLAB even existed. And another great example is especially kind of some of the new state-of-the-art algorithms and libraries that, the developers will decide, hey, this is good, we should bake this into the product. So, for example, there's a Highs library. It's a optimization library that's now in the optimization toolbox as one of the solvers. So that's one example. There's a whole bunch that we've tested and maintained, and especially when you get into certain kinds of optimizations and other kind of specifics, like in image analysis and things like that, there are pretty specific ones. So lots of really good examples of open source inside of MATLAB and Simulink. And then alongside that is also quite common. And that's kind of where you're doing, your interoperability. You're using the two languages together in some kind of pipeline or workflow. A lot of what we talked about in the last podcast, that's kind of what we're seeing, especially with Python being so popular for AI and analysis. And of course, C++, people have been doing that for a very long time with MATLAB. And so that's kind of the idea of developing side by side, or kind of stitching together in a pipeline. Like say you're deploying and you use a bit of Python, you use a bit of C, you use a bit of MATLAB, that kind of workflow or pipeline where you're stitching everything together and then ultimately deploying. We see quite a lot, again, those kind of side by side, many different languages all together to solve that problem.
Yeah, you already mentioned Python, Heather. Some of the best practices for integrating OSS into MATLAB, particularly when it comes to maybe using software such as Python. I think the audience might be not aware of what is actually possible combining different types of software. You mentioned C++, they have an optimizer. Some of my colleagues have been using it for writing their master thesis. But when it comes to Python, which a lot of people use, do you have some examples maybe of how we can combine MATLAB and Python?
Sure. Yeah. And yeah, sure. There are so many different ways that people want to work with these together. And I think Python's a great example of that because there's so many different ways that you might have your code organized, right? Sometimes maybe you're just copying and pasting something. So if you're, let's say you're a MATLAB developer, okay, let me step back a minute. We see people doing, MATLAB as the sort of IDE of choice, and then bringing in Python code, or using this to kind of develop side by side. And then, of course, vice versa, you're kind of Python primary for that project, and you open up a MATLAB app and you use a little bit of MATLAB. The other thing that we see is and I'll talk more about all these, but the deployment part where, it's less of that development phase where you're kind of working side by side, you have both things running together. It's more like, okay, I'm all set with this MATLAB code. I'm going to hit a couple buttons, deploy it, send it over to my colleague or in this other part of the project where that person doesn't need MATLAB license or access or whatever it is, So that kind of, development phase and then that deployment or more of the operational sort of phase, we see a lot of that. So that said, whenever you are calling Python from MATLAB, I have to go slowly because I always get them confused. There are many different ways to call that code depending on how it's organized. So I started kind of jumping into this earlier, but again, let's say you just found something that was really useful. You want to copy paste it. You can do that. There's actually a live task in MATLAB that is literally just like a little baby Python thing that you can just copy the code into and just carry on. And then a variety of other different ways to run, again, based on how you've organized things, quite easy. Similar to the calling MATLAB from Python, right? So the other way around. Some of the things that, for best practices, we want to think about the setup, making sure things can talk to one another. That's kind of always the way of things whenever you're working in different languages. And data types. So those are some of the challenges that people will see whenever you're doing that development phase, again, having both of them running, doing stuff. The data type mapping is generally a challenge, or at least something you have to think about. And a lot of the times, of course, we can share some of these resources, but there are cheat sheets, there are good pages in the documentation where it kind of shows you that mapping. Generally, the lowest level data type will work. The floating points, the integers, those kinds of things. There's not generally any kind of problem. You don't have to do a lot of work for that. But the more, I don't want to say complex because I'll get in trouble by the math people, the more complicated data, like heterogeneous types like data frames or dictionaries, those kinds of things, that's where you need to think a little bit. And one thing people, because I talk to people all the time about this stuff, they always complain and they say, why don't you just change it into a table? It's a dictionary. I'm going to want a table. Well, depending on what you do with it, I don't know if you want to change every single data type inside the dictionary. Maybe you don't even need any of it. Maybe you just need one little number in there and you can just index right into it. And you don't have to spend all that time casting and converting and, those kind of bottlenecks that you generally have in these processes. So I think that's one of the challenges, especially with, no offense, everyone, MATLAB developers. We're used to solving problems. Quick, do it. Give me an app, give me a thing. I got to solve this. I got to get the frequency domain. Let's go. But, it's often that you have to step back and maybe write it all out, kind of figure out your pipeline. Like, where does it make sense to convert the data? How much do I need to convert? A little bit more of the traditional kind of DevOps types of things, not to scare anyone, but just think about it a little bit before you get started and you think about what you need. You don't have to start changing every single, vector inside your dictionary if you only need a couple of values. So that's something that, you know, we sort of, or at least I encourage whenever people are getting started with these projects, just sort of think about what you're trying to do with it, what makes sense to do in each language, you know, the data back and forth, again, something to really think about. And yeah, having some of those development practices in mind, like writing it down first or thinking about it ahead of time.
Mm-hmm. Super cool summary, Heather. I love it. How has it been perceived from the community itself? Like, does there have to be kind of a mindset shift, or are people like currently going through a mindset shift in terms of like, okay, I can combine Python with MATLAB? Is it something new for people, or is it something that's currently developing?
Yeah, that's a great question, because I think there was less familiarity with it, right? The functionality was introduced back in like 2014, which is 300 years ago now. So I think that there were a few kind of early adopters, but as more people became aware of it, just like the open source community does, you know, we hear feedback, people get excited, they want a little of this, want a little of that. And so it really helps the development teams be able to prioritize and keep working on it. And one thing that has been really exciting for me is, you know, I'm thinking back to my career and, you know, some of those times where I would be in Python and I'm thinking, man, wouldn't it be nice to just open up the signal analyzer real quick and like just do my app thing? Well, you can do that. Like, that's awesome. You know, so I think you're right about that mindset shift where people are thinking like, oh, well, wait a second, like, what are those cool things that MATLAB can do for me? And I can just open it right up. And Simulink, of course, is huge. I know that your audience, you know, a lot of controls folks and people that kind of spread engineering, you know, the entire world of engineering. And so we're seeing a lot of people very excited about using Simulink with Python, where, you know, you can, you know, you're in Python, you're in Jupyter doing your thing, and you run a simulation and just have Simulink going, right? So that's extremely, extremely powerful, because, you know, previously you would have to run the simulation, save the data, bring it in, and do all this kind of back and forth with data management and files and things like that. And now you could literally optimize or, you know, do some kind of parameter sweep with your simulation in Python. So, you know, pretty much every release, there's just more advancements because of that, you know, excitement and hearing more and more about what people want to do and trying to make that easier. Great example is pandas. So traditionally at MathWorks, we only test the base language, right? So it, you know, there's a very significant test suite at MathWorks, and it would be very challenging to keep up with every single time someone updates every library that's ever been used in every language. So no thanks. But what we've been doing is starting to actually soften that a lot, where we know that people are using TensorFlow. We know people are using PyTorch, pandas, you know, these really popular NumPy, you know, things that are extremely popular. Well, why not bring that in and test it and make sure we're good to go here, you know, and make it easy. So talking about the dictionaries and some of those more complex data types, there's now a data frame to table converter, right? Just to make that easy. You don't have to unpack everything. If you want all of it converted, done. And, you know, if you're in or if you're in Python, same thing. So I think that's one really exciting advancement, something that is new, or, you know, again, testing libraries that are really popular, and the more that people are using them and communicating with us, just like the rest of the open source world, we want to know, and we can help.
Yeah. One thing, I mean, we've talked a lot about benefits, Heather. I think one thing that would be interesting for the audience is, I mean, let's say I'm a techie, I'm an engineer, I love my code, I love being, I don't know, like a crack in what I'm doing. Then I'm writing Python code and I'm thinking, well, I could potentially use MATLAB, but why would I do that? Or why would I use Simulink? Is it just maybe I don't want to do it? Like, what motivates me as an engineer to go from Python and maybe try the MATLAB way or the Simulink way? Why would I do that?
Yeah. All right. You know what? Don't bother. Just go back and use. You're fine. Never mind. I'm out of here. Just kidding. No, I think that's a really, really fair question. Sorry, I get excited. Because I think my very short answer is, how much time do you have? Like, how much time do you have? Because, if you need to be messing around with new library, old library, incompatibilities, those sorts of things. And I love to write code. I absolutely love it. It's my thing. I love all the little indentations and stuff, but I love my time. And so if I'm trying to train a machine learning model and I'm like, oh, yeah, I'm going to pop open the classification learner, hit 2 buttons, one to do parallel and one to just train all, go get a coffee, mess around with my stupid Python library things that I was struggling with earlier, and then come back and it's all trained and I can make a decision. I didn't have to write a whole bunch of code and things like that. So those are the things that I tend to, myself, I'm a Python developer as well. So, I mentioned kind of just opening up the signal analyzer or, I don't know, it's kind of uncomfortable entering the frequency domain. I like to have the visualizations and the apps and things like that. And especially finding that, a lot of Python work in the engineering community and the research community is in the data stuff, right? Data management, data analysis, stuff like that. And when it comes to a lot of, engineering kinds of things, there's time series that is horrible to, deal with outliers and missing data. And you're like, oh my God, what method do I use? Open up a textbook or something. But so those apps where you're just like, let me try this one. Let me see the visual. Let me try this one. I'll see the visual. Like, okay, I can decide in like 2 seconds, like 10 minutes maybe, to just like try all of them and be like, this one makes sense. Moving on. I'm not sitting there with documentation and, mans trying to figure out how to write the code and like coming up with some little test thing to see which one's going to be the best. Nah, that's good. I'll just use this app that extremely smart people have built for me. So anyway, that's where I see the value.
Yeah, that makes sense. We talked about ROI, Heather. I'm wondering, like for a student like myself, let's say you're procrastinating on your thesis and you have to get something done, then maybe I might think about maybe using the combination of Python and MATLAB. For industrial applications, like how do you guys not maybe calculate the ROI explicitly, but more like when does it make sense to combine these tools? Like, is there kind of a specific threshold where I would say, or what you guys would say, now it's time to actually use kind of the interoperability between Python and MATLAB, for example?
Yeah, that's a great question. And I think that what we'll find is, especially when you're working with large teams, I'm sure you and a lot of your audience knows that these engineered systems are extremely complicated. There are huge teams working on this from all across the world, all across the organization and doing all sorts of different things. And so those are the times where, you have your data scientists or your AI people working in Python or, PyTorch, whatever, and you have your, sensor people working in MATLAB, and you have simulations going on in Simulink and tests going on in some C++ thing. That's absolutely where you want to start thinking about integrating, because then you don't have to rewrite anything. If your deployed or your end result, let's say, is in C++, previously you would maybe take that TensorFlow or PyTorch model, oh God, that gives me a headache, and make that into C++. You would take all your signal processing, make that, and then have your C++ person with all their hashtag includes and all this stuff, stitching everything together. Like, that's where you want to do this, because it's easy to co-develop, like I was mentioning, where, okay, this guy gave me, this lady gave me some Python, this guy gave me some C++, I'll just put them all, open everything up, make sure the data types are working before I send it on, or, push it to our repo and things like that. So that's definitely one place where it makes sense. And I think the deployment part is another one where it's like, I've seen people, it's just hilarious to me, but like they have their entire application is in Python, and they only use MATLAB as the MATLAB production server because it's really easy to just like hit a couple buttons, you get a README, you get a install thing, you get set up. So it's like, yeah, why not? It's just you use whatever makes sense, whatever is the fastest, easiest thing for that part of the job. And then the other time is when there's some kind of state-of-the-art algorithm that you're just not able to see, kind of side by side. or you don't have it in MATLAB or you don't have that in Python, that's where it's really easy to just be like, oh, fine, I'll just call blah blah blah. No big deal. It's like just like anything else. So I think that research phase is also where you see that again, there's no need to if there's some sort of certain kind of algorithm, there's no need to recreate that algorithm in all the weird parameters in MATLAB. Just call the Python one, no big deal.
Mm. How do you see, we talked about this a little bit about the mindset shift, but is there a general trend maybe in software development when it comes to OSS and particularly MATLAB and Simulink? Is there kind of, I don't know, a micro trend, a macro trend that's happening? Because you have more insights than I have. Is there more people joining the crowd? What's happening at the moment? How do you see the movement going?
Yeah, it's absolutely excellent. So, like you said, I think we're just getting started, honestly, because one of the big exciting things is that we're really engaging with the community developers. Like the people that invented Highs. We've been in touch with them. We've been supporting them, and in more ways than just through the repo. So I think the more that we find people that are excited about it too, like reached out to the developers and they're like, wait, seriously? You're putting our thing in MATLAB? Like, that's so cool. Like, tell me what you need, So we're going to see so much more of that. And every release, there are just more, open source algorithms. Like, this is kind of where the world is heading, right? So I think that there's a lot more excitement. And, there are a lot of MATLAB developers that don't think of themselves as proper, software developers or proper coders like me. I'm a scientist. I want to solve problems, but I can do this with software. But I think there's a lot of excitement about participating in this world. And if you're a good MATLAB developer, come on in. We need some algorithms. We need tests. So I think there's a little excitement around that too, where I can put like my GitHub thing on there. Like, I'm not some crazy, like in the weeds Python developer or like C++ thing, but like I have a graph of the Marvel universe. Maybe somebody is interested in that and they want to help, and I can share things this way. And it's not as intimidating, I think, as some of the sentiment previously when it came to contributing and really interacting with the open source world. So you're right. There's definitely a mindset shift in this, and we're just going to see even more and more again because of that excitement.
Yeah, I feel also with the interoperability going back, I feel like especially in engineering, there's kind of a trend towards this more low-code approach or no-code approach, where you have like blocks like Simulink, you connect different types of software from the CIE world, so computer-aided engineering world. And here it feels like you can switch to whatever you want. You have high code, low code, and if you want no code, so you kind of can combine whatever you need at that point in time, which is super cool. But I think, MathWorks is probably one of the best, if not the best, when it comes to learning resources. Like you can literally find anything about MATLAB online or Simulink, which is pretty cool.
Yeah, and it's great because we're also sharing more resources about Python and MATLAB and working with other languages. Like I just made a cheat sheet that I'm updating for MATLAB for Python users because, as you know, it's fairly similar syntax wise. If you're a Python developer, you could be an excellent MATLAB developer. And likewise, you just have to remember about the brackets and that it starts at 0 and 1 or whatever, typical stuff. So I think there's a lot of, you're right about that. And again, those kind of MATLAB people that started kind of ramping up with coding, I think we've seen a lot of excitement that they like, oh, I could be a Python developer too. And like, I can just use this stuff. Like, it's actually not that bad. And like, you're actually helping me. That's amazing. Like, thank you, MATLAB. So yeah, I think that's a great point. The learning resources. I think there's even a 2-hour training on the training services website where you can go through it. It's free, how to integrate them together. So it's a great point.
That's cool stuff. Yeah, we'll link every resource that's relevant for this podcast down in the description so people can check it out for free. I'm wondering, we talked a lot about more the end user, right? Like the engineers, like people like you and I, Heather. how do decision makers perceive kind of this interoperability? Because then the arguments become much more different in terms of time saving, knowledge capturing. Like how do you communicate that to decision makers?
Yeah, that's a great question. And I think it actually kind of goes back to what I was saying about how the more kind of expensive or useful projects that people are working on tend to be large teams, and you don't need to have this big fight, the holy wars between languages and between teams, and like, you people, why are you using MATLAB? Well, you're crazy using Python. You're crazy. Your teams do not have to fight about that. Nobody has to read you any work. You make an algorithm, that other team can use it, no problem. And then that deployment part, especially if your end result or your product has needs to have those things, that's where it's really valuable. I think that, again, I don't know if you've used the deployment or the compiler things in MATLAB, but like, I can't even imagine a world where I'm trying to put something on hardware and I have to take a machine learning algorithm and recode this or check all of the C++. I'm like, that just sounds so expensive. Even for a super amazing developer or a whole team, like, why would you want to do that? Mm-hmm. Hit a couple buttons, get that README, get that set up, get the setup.py all ready to go. Like, you don't need to you hire extra people to stitch all these things together. There's a lot of value in that. Just using the best tool for the job quickly, easily, time is money, and everyone's supported. There's no infighting about or arguments about what language we should use for what project. Use whatever you need to do. It's fine. We'll figure it out. Mm-hmm.
That's cool. Yeah, it goes back to the podcast side with Paola, where she talked a little bit about how to do use case analysis, more in terms of like AI and like embedded devices, but that's really, really cool. We talked about resources. Is there anything else that is important that we might have missed, Heather?
I guess I'll just say that we are my colleague, Mike Croucher, and I think he's been on the podcast before too, right? Mm-hmm. He's what a great guy, and super advocate and very knowledgeable about the open source community. We're doing a MATLAB Expo talk together, so that is going to be on November 13th. We'll, of course, put some links to that in, sure, but there'll be video recording if you can't make it. But we'll be talking about this very subject, about those three things that, open source on top of, inside, and alongside MATLAB and Simulink, and sharing some of our experiences. And you'll get to see the Marvel graph that I made. It's pretty exciting. But anyway, that'll be a great way to keep in touch, follow up, and a great way to keep in the conversation. And that's what open source is all about.
Yeah, what I really love, and maybe this is kind of a closing remark from my side, Heather, is like that you guys in MathWorks are not like the typical sales guys. You just talk about how you think about a specific topic, especially you, Jan, Toshi, and the rest of the team. I think it's much more, it's also about the honesty, because if you would just sit there and say, MATLAB is great, just buy from us, I think that would not be honest probably. And you also have the open approach and saying like, we work together with OSS, with the community, and like grow together, which I really, really love.
Yeah, and we're grateful for it. This is how science works, right? How math works. We're all trying to get to the same goal, and improvements, in our world. So I agree, and I thank you for allowing me to come here and talk about it. I think, like you said, we're not built that way. I can't lie to you. I'm not. It's just not how I am. I'm a scientist. Physics does not allow that. There's no tolerance. So I couldn't do it with a straight face.
Excellent. Heather, thank you so much for being on the show. And there's probably an opportunity to talk again on my podcast in the near future. So let's see what topic we're going to cover in the next one.
Hopefully, yes. I'd love to come back again. Always a pleasure talking to you.
Thanks, Heather.
Thank you.